All right, guys. Quick little review of exponents and exponential growth. I hope you guys watched the videos. I know the video with the grains of rice said it was in India. Obviously, it's a legend. I've heard it attributed to Persia. I've heard that the man invented chess. I've heard that he was a poet and brought the king, his poetry, and then got payment via the chessboard. But essentially, it's always the same problem that there's a chessboard and you're going to double the grains of rice. If you watch the other video with the Hall of the Mountain King music, that do 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 do, what they were doing, I don't know if you could tell from the video, is they were showing pretty much how it would fill up the chessboard and then how it would fill up their house. And then it zoomed out a little bit. So I just want to show you guys something. I'm pretty sure the people who made that video were in Switzerland because they focus on Switzerland. Either that or they just figured out that that's kind of a right fit for that number of grains of rice. So here's Switzerland, right? Notice it's separated. It's in between Italy, France, Germany, and Austria over here. I think there might be one of those micro republics near Liechtenstein or something. But anyways, so here's Switzerland. So that was their final thing. They filled up all Switzerland. But then before that, they were from Basel, so they were filling up the town of Basel first, right? So if you notice, they started up here at the top of the map. And then if you notice, at one point, it was the floor plan of a building, and that was one of the cathedrals and the big churches in Basel. So it was filling up their house. Then they picked the next biggest thing, which would be this gigantic cathedral. Then it was filling up their town. Then it was filling up the entire country of Switzerland. Okay, so it was changing in scale, if you guys didn't get that. Okay, so pretty much what we want to do is we want to look at that pattern that we talked about, right? There's 2 to the first power is 2, right? 2 to the second power is 4. 2 to the third power, right? 2 times 2 times 2 is 8, right? So we want to take a look at that pattern a little bit today. So let's take a look. So we know that 2 to the first power is 2, right? 2 to the second power, right? 2 to the second power is 2 times itself 2 times. 2 to the third power is equal to 2 times 2 times 2, which we just said was 8, right? And if you notice, these are doubling, right? If I double 2, it becomes 4, right? If I have 2 things and then I double it, it becomes 4. And then if I double the 4, it becomes 8, right? And if I double the 8, it becomes 16, right? And if you'll see, these numbers get bigger and bigger and bigger, right? So 2 times 2 times 2 times 2. Now, eventually, they might get a little bit too big for you guys to do. You break out your calculator if you want. 2 to the 5th power is going to be 32, right? And again, I know what 2 to the 6th power is, but if you were confused, right, you say, what is 2? And to get your exponent, you see this symbol here is called a caret, this little arrow. 2 to the 6th power will be 64. Okay, 2 to the 7th will be 128, and 2 to the 8th will be 256. I'm going to give you a few more just because I'm going to show you what is one of the things they use this for. 2 to the 9th is 512, and 2 to the 10th is going to be 1028, 1024. Sorry about that. Okay. So where do we see these numbers in everyday life? And chances are, if you are working on a computer right now, which you probably are, or using something like an iPhone or an iPad, these numbers come up a lot, these numbers. So if we take, for example, where did I break it out? iPads. So I went to Best Buy, I looked up iPads, right? If you notice how much memory is that, there's 128, right? That was one of our numbers. It's right here, right? That's one of our numbers. What else do we have? I've got 128, 1 terabyte. I'll get to that in a second. But what do we got? 1 terabyte, 256, 256. Again, that's another one of our numbers. And that terabyte, by the way, is actually this one right here. They rounded it. They said it was a terabyte. It was 1,000. Okay, they rounded it, but it's actually 1024. And what they do is the little piece of memory inside the computer, all they do is they double them. They put 2 in there instead of that, okay? Or then they put 4 in there instead of just those two. So all they're doing is doubling the amount of memory they have inside of them, okay? So you'll see these numbers show up a lot. There's 512 right there. That was another one of our numbers, okay? So again, all they're doing is doubling the memory. So if you saw when the iPhones and the iPads first came out, they were very low. They were 32, 16s, and 64s. Now that they've become bigger, bolder machines, they require more memory. The other thing you might see is actually in the computing power of your device, and you'll see that here. They're not all that way, but if you notice, 4 is one of those numbers we have, 8 is one of those numbers we have, 16 is one of those numbers we have, right? 32 and 64, right? And that's the processing power of your computer. Now there's a couple other ones in here, but for the most part, we noticed these are all those doubling numbers, okay? And what they mean is they have one unit that they start out with, and instead of putting in 1, well, they put in 2, and it becomes 8. Well, if I want 16, I just put in 2 of the 8s, okay? So you just put in extra units and things like that. And as you can probably guess, the more that you put in, the more expensive your device becomes, okay? So what we want to do today, too, is also follow the pattern in the other direction, okay? So if going up we doubled and doubled and doubled and doubled, what happens when we go in the opposite direction? Well, if we double going up, right, then what we did coming down is we actually cut it in half, right? 256 cut in half is 128. 128 cut in half is 64. 64 cut in half is 32. 32 cut in half is 16. 16 cut in half is 8. 8 cut in half is 4. 4 cut in half is 2. What's 2 cut in half? Well, if I have 2, I cut it in half, all I get is 1. And if you guys remember, one of the important rules which says anything raised to the 0 power is 1. So that's a weird anomaly that happens, right? But if you don't believe me, you break out your calculator and say, hey, what's 2 raised to the 0 power? And it's going to tell you that it's 1, okay? Now, I know for the rest of these, for these negative numbers, your ambition is initially to be saying, all right, I'll just put it in the calculator. I don't want to deal with negative numbers. I hate negative numbers. I'll put it in the calculator. But I do want you guys to recognize something. This pattern, right, 876543210, continues with the negative numbers, right? They just go in the opposite direction. This still does the same thing. So what do? We cut in half. What's half of 1 is 1/2. What's half of a half is a quarter. What's a half of a quarter is an eighth. So we keep cutting down by a half, and what you'll see is this. 2 to the 1 is 2. But 2 to the negative 1 is 1/2. Right? You see that 2 on the bottom there? 2 to the second is 4. 2 to the negative second is 1/4. 2 to the third is 8. 2 to the negative third is 1/8. So all we need to do is take the number we got up here and throw it on the bottom of a fraction. So if I said 2 to the negative 4th, well, 2 to the 4th is 16, so that makes this 1/16. Okay, 2 to the 5th was 32, that makes this 1/32. Okay, 2 to the 6th was 64. 2 to the negative 6 is 1/64. Okay, 2 to the 7th is 128. 2 to the negative 7th, 1/128, and 1/256. Okay, so what happens is a lot of people say, all right, well, 2 to the negative 8, 2 to the negative 8, fantastic. So I'll go in there, I put a 2 raised to the negative 8, okay? And it gives you this. And you look at that and be like, there you go, that's the answer. It's important to know where this number comes from, and what it is it's 1 divided by 256. Okay, same thing, okay? So there's another column if you guys want to try it out with 3s. You'll see the 3s grow even faster, and we'll talk about some other stuff tomorrow, okay? Have a great night.